Hey everybody. In class today we focused on how to graph linear inequalities. Tonight we are going to practice writing linear inequalities from the graph. Okay, we're going to do 4 examples, and this is pretty straightforward step-by-step stuff, so follow along and I think you'll get it. Now remember when we were graphing linear inequalities, we always started with the boundary line, right? We're going to do the same thing here. The first thing we're going to want to do is write an equation for the boundary line. Okay? Now, that'll give us something to work from. It'll give us 2 variables, it'll give us an equation, and then we're going to change it into an inequality. So we'll write an equation for boundary line. And then step 2, we are going to change to inequality. We'll abbreviate that. So I'm looking at our equation, or our inequality we have here, right? We have this line, we have this side shaded in, this is where all the solutions are, and this is a solid line. So we know those points on that line are also solutions. But right now, I'm just going to write an equation, write step 1 here in red, and I can see what the y-intercept is here, right? We got a nice little y-intercept right here, we know exactly what it is, so I'm going to use slope-intercept form, y equals mx plus b. So I know my b is going to be -1, and I know my slope is down 1 to the right 1. So if m equals -1 and b equals -1, my equation is going to be y equals -x minus 1. Okay, so that's the equation of my boundary line. So that just gives us this line right here. We got to figure out how do we make it so that we are showing all of the solutions in our inequality too. And that's where step 2 comes in. We are going to need to change this to an inequality. Now I can pick any point that I have in this solution set here. So on this part of the graph, we don't need to pick a point on the line because we already have the line represented. So I'm going to pick this point right here. I'm going to pick 0, -3. I know that's a solution. So when I plug that in to my equation for the boundary line, that's going to tell me which way my inequality needs to face. So this point is 0, -3. So I'm going to plug in -3 for y. I'll plug in 0 for x, and we'll subtract 1 there. Now this gives me -3 and -1 over here on the right. Now I got to figure out what inequality is going to have to fit into this space in between those numbers, right? Because this is no longer equal to. We're not equal to anymore. And -3 I see is less than -1. So this inequality right here that we just found, this is going to be the inequality in our expression for the graph. So we're going to write our borderline equation now. We have y on the left, we have -x minus 1 on the right, and instead of the equal sign like we have here, we're going to put in the inequality. So we're going to put less than, y is less than -x minus 1, and we also have to include equal to, less than or equal to, because of the solid line right here. Okay, because the line is solid, this has to be less than or equal to. Let's take a look at b. Let's try another one here. So I'm going to need an equation for the boundary line again. Once again, we have a nice y-intercept, right? b equals 1. And now we need to find the slope. I can use this point here, and I'm going to go up 1 and to the right 2. So my slope is 1/2. Now I can write my equation using slope-intercept form. Y equals 1/2 x plus 1. Once again, I'm going to want to use a point that is in my solution set, right, in this shaded area over here, to decide which way my inequality is actually going to face. Now, I like these numbers, or I like this graph because I get to use 0, 0. It's always nice and easy. So we'll put in 0 for y. I'm going to leave that space in between blank. 1/2 times 0 plus 1. Okay, remember we're trying to figure out what inequality is going to have to go here. So 0, and then I have 1/2 times 0 is 0, plus 1 is 1, and my inequality has to be less than, because 0 is less than 1. So when I write out my inequality, I have y, I have 1/2 x plus 1. I'm going to put less than here. Y is less than 1/2 x plus 1. And because it's a solid line, I know that it's less than or equal to. So y is less than or equal to 1/2 x plus 1. And that is our final inequality for that graph. All right, let's do our last two examples here. In example C, label that C and D. In example C, we have an inequality, but we don't have a diagonal line. We have a vertical line. Remember, vertical lines always have the form x equals a, right? All of the x values are the same. It crosses through the x-axis, but it has an undefined slope. So there's no y in this equation, just x equals a number. And in this case, that number, the x-intercept, is -3. So our equation for the boundary line is x equals -3. That's the vertical line. Now, to find the inequality here, we're going to do the same thing. We're going to pick any point that we want. I'll just pick this point right here in the shaded region. That is -1, -2, -3, -4, 0 are the coordinates of that point, and we'll substitute those values in for x and y. Now, I don't have a y, so this is just going to look like this. -4 in for x, and then we have -3 on the right here. And I got to figure out what inequality goes right here. And we see that -4 is less than -3. So when I write my equation for the boundary line without the equal sign, I'm just going to replace the equal sign that was here with this inequality. X is less than -3. And if we look at our graph, that makes a lot of sense, right? All of these x values are less than -3. And the reason here we're not going to have less than or equal to is because we have a dashed line. Remember, that means that none of these points on the line, including -3 right here, are solutions. So the only solutions are the values that are less than -3. In example D, we have another dashed line, so that tells us something already, but we are just going to do the same thing. We're going to write an equation for it. Now, here I don't see a very clear y-intercept, so I'm actually going to use point-slope form for this one. I think is going to give us the easier time for writing the equation. So I can pick any point I want. I'll just pick, we'll go with -1, 3 here. So I have y minus 3 equals, I got to find my slope, so I have to go down 1, 2, 3, 4, 5, down 5, and to the right 1, 2, 3, 4. So my slope is -5 over +4 times x minus -1. I'm just going to write +1. Okay, so there is my equation here in point-slope form. Now we have to do the same step where we figure out which way we are going to shade. As usual, I'm going to try to pick a number, a nice number, where I get to use 0. So let's go right here. We'll go, that looks like 0, 3 for our point. So we substitute our values. 3 minus 3. I'm going to leave this equals, the space where the equal sign would go blank. We're going to figure that out later. -5 over 4 times 0 plus 1, putting 0 in for x. So 3 minus 3 is 0. -5 over 4 times 1, because 0 plus 1 is just 1, -5 over 4 times 1 just gives us -5 over 4. So in this case, 0 is actually greater than negative 5 over 4. So this is the inequality that we're going to replace this equal sign with. So we're just going to write out the boundary line as we had it, y minus 3 on the left. We got negative 5 over 4 times x plus 1 on the right. And here, where the equal sign was, we put greater than. And like I said earlier, when I noticed the dashed line, it told me something. I know that it's not going to be greater than or equal to. It's not going to be less than or equal to. It's just going to be greater than, because the points on this line, because it's dashed, it tells us that they are not part of the solution. So this is our final answer right here for the inequality that matches this graph.